Okay, next isomerism is stereoisomerism. So here same bond connectivity but different arrangement of groups or atom in space. The isomer which have same bond connectivity but different arrangement of groups or atoms in space, they are known as stereoisomers. So this branch of chemistry dealing with the study of three-dimensional nature and spatial arrangement, three-dimensional nature and spatial arrangement of molecules is known as stereochemistry. So metabolic activities in living organisms, natural synthesis and drug synthesis involves various stereoisomerism. So among the stereoisomerism, first we are going to see is geometrical isomerism. This is a stereoisomerism which have different arrangement of groups or atoms around a rigid framework of double bond. So geometrical isomerism is only for double bonded. Okay, this is due to the restricted rotation of double bonds. This underline panikino, you have to underline restricted rotation of double bonds or about single bond in cyclic compound. Double bonds la you can see this, but in single bonds cyclic compounds la you can see this geometrical isomerism. So in alkenes, the carbon-carbon double bond is sp2 hybridized. The carbon-carbon double bond consists of a sigma bond and a pi bond. I told you how a sigma bond and a pi bond are there in double bond. Pi bond is formed by the head-on overlap of sp2 hybridized orbital and sigma bond and pi bond is formed by the sideways overlap of p orbital. The presence of pi bond locks the molecule in one position. It locks, the pi bond locks the molecule in one position and not allow it to rotate. So rotation around C double bond C is not possible. This restricted rotation of CC double bond is responsible for geometrical isomerism in alkenes. So if you see here, this is cis-trans isomerism. I told you two similar groups. This is one group and this is another group. Two similar groups. If on the same side, we call it as cis. If the similar groups are on the opposite side, we call it as trans. This is cis-trans isomerism. This is cis-trans isomerism. Now, the two compounds are termed as geometrical isomerism and are distinguished from each other by the term cis-trans. Cis is one which two similar groups on the same side of the double bond. Trans one the similar groups are on the opposites of the sides of the double bond. Hence, this type of isomerism is called cis-trans isomerism. The cis isomer can be converted into trans or vice versa only if either isomer is heated to a higher temperature or they absorb light. So about 62 kilocalories per mole is required to break the pi bond. Appo cis can be converted into trans only when the double bond is broken, that is the pi bond is broken. So to break that bond it needs 62 kilocalories. Okay, so upon cooling, so the heat பண்ணும்போது நடக்குது, cool ஆகும்போது திருப்பியும் it comes back to the cis trans. Trans வந்து cis ஆகும், cis வந்து trans ஆகும், it will change. So the example that is given here is cis 2 butene and trans 2 butene, trans and cis. So inga paru, here you have a compound, you supply heat. Okay, you supply heat. Here இங்க வந்து CH3 இங்க இருக்கணும், இங்க CH3 இருக்கணும். Okay, so CH3 trans இங்க ஒன்று this is trans. Okay, heat பண்ணோனே இது சிஸ்ஸா மாறுது, cool ஆகும்போது again it is, so it is reformed to cis. Okay, on cooling it is again converted into trans. Now the main thing is trans isomer is more stable. Trans isomer is more stable. This is very important. Trans is more stable than cis. The reason is cis has bulkier group on both the sides. Inga par. This is cis, so bulkier group. CH3 is bulkier when compared to hydrogen. Both the bulkier groups on the same side. So there will be steric hindrance. Adjustment problem will be there among them. So always their energy will be more. So cis is less stable. Whereas trans the groups, bulkier groups are on the opposite side. So their energy will be less and they will be stable. The cis and trans isomers have different chemical property. This can be separated by fractional distillation, gas chromatography, etc. All alkenes with identical substrate do not show geometrical isomerism. Geometrical isomerism is possible only when each double bonded carbon atom is attached to two different atoms or groups. In propene, no geometrical isomers are possible because one of the double bonded carbon has two identical hydrogen atom. Okay, next one, 1 comma 2 3 butadiene. Diene na two double bonds you have. Okay, in conjugation no alternate fashion. It can exist in infinite number of conformation, but the following two extreme conformers are important. இது cis transla. இப்போ oxime and azo compounds. இப்போ இதில் வந்து என்னன்னா the restricted rotation is seen with carbon and nitrogen. It is seen here with carbon and nitrogen. Okay, so it gives rise to geometrical isomerism in oxime. Oxime வந்து NOH இருந்ததுனா, COH னா நம்ம என்ன கால் பண்றோம், alcohol. ஆனா NOH இருந்தா the name given to is oxime. Here syn and anti are used instead of cis and trans. Syn isomer, the hydrogen atom of a doubly bonded carbon and OH group of doubly bonded nitrogen lie on the same side. See, hydrogen and OH. While an anti-isomer, they lie in the opposite, H and OH. Okay, this is with respect to oxime. Syn na cis, anti na trans. Name of the compound acetaldoxime. Next, that is with respect to geometrical isomerism. இப்போ எதில் இருக்கும், stereoisomerism. Stereoisomerism is classified into two, geometrical and optical. So we finished with geometrical, now it is optical isomerism. Optical நாலே என்ன வந்துருது, light வந்துருது. Okay, so light வந்துருச்சு அப்படின்னா compounds having same physical and chemical property but differ only in the rotation of plane polarized light is known as optical isomerism, and the phenomenon is known as optical isomerism. Optical isomers, optical isomerism. இப்போ I will tell you what is this plane polarized light. இப்போ normal light எடுத்தீங்கன்னா it has reflections on all side. Normal light, when this is passed through a nickel prism, nickel prism, the light is passed through nickel prism. This has reflections in all direction, but when the light passes through this nickel prism, okay, the emerging light, what do you mean by emerging light? The light that is coming out will have reflections in two direction. ஒன்று வந்து clockwise, இன்னொன்று anti-clockwise. This is clockwise, this is anti-clockwise. Clockwise is given the symbol D, anti-clockwise is given the symbol L. So this light that comes out of the nickel prism will have deflections in only one direction. That is called as plane polarized light. அப்போ இந்த ஆப்டிக்கல் ஆக்டிவிட்டிக்கு என்ன இருக்கும், plain polarized light இருக்கும். Some organic compounds such as glucose have the ability to rotate the plane polarized light, and they are said to be optically active compounds, and this property of compound is called optical activity. அப்போ என்ன அப்படின்னா, இப்போ குளுக்கோஸ் எடுத்துக்கிட்டோம், குளுக்கோஸ் இஸ் அ காம்பவுண்ட் தட் ரொட்டேட்ஸ் தட் பிளெயின் போலரைஸ் லைட். அந்த பிளெயின் போலரைஸ் லைட் when it is passed through glucose அப்படின்னா it rotates the light either to clockwise or to anti-clockwise. If it rotates in the clockwise direction, it is said to be dextro-rotatory, denoted by the sign plus. Whereas anti-clockwise left na, it is called as levorotatory. Dextro-rotatory, levorotatory, denoted by the sign minus. Dextro-rotatory is represented as D and levorotatory is represented as L. இப்போ next வந்து enantiomerism and optical activity. Optical activity அப்படின்னா an optically active substance may exist in two or more isomeric forms which has same physical and chemical properties but differ in the term of direction of rotation of plane polarized light. Such optical isomers which rotate the plane polarized light with equal angle but in opposite direction. Equal angle, right side திரும்பி 60 degreesல திரும்பிச்சுன்னா left side 60 degreesல தான் அது rotate பண்ணும். But in opposite direction, they are known as enantiomers. So same magnitude, magnitude na another number. Okay, the rotation will have same magnitude, but the rotation will be different. Direction, sorry, rotation of direction will be different. Same magnitude, rotation of thing will be different. Direction, rotation of direction will be different. So this is known as enantiomers and the phenomenon is known as enantiomerism. Isomers which are non-superimposable mirror image. Non-superimposable mirror image அப்படின்னா take your right hand and keep it over the left hand. Overனா மேல. அப்போ வந்து your small finger of the left hand will be below the right thumb. அப்போனா it is non-superimposable. Now you say vanakkam. When you say vanakkam, you join both the hands. So small finger with a small finger, ring finger with a ring finger, all the fingers will be imposed on each other. That is superimposable. Whereas when you take your right hand and keep it over your left hand, it is non-superimposable mirror image. Appo isomers which are non-superimposable. Isomers which are non-superimposable mirror image of each others are called enantiomers. They are called as enantiomers. So condition for this enantiomer or optical isomerism. Now I told you today, carbon atom has valency what? 4. Okay va? அப்போ அந்த 4ல வந்து it has to be attached to 4 different groups. 4 different groups. Can you see here? It is satisfied by 4 different substituents. When it is substituted with 4 different groups, it is called asymmetric carbon or chiral carbon. It is indicated by an asterisk, C asterisk. Can you see here? C asterisk இருக்கும். A molecule possessing chiral carbon atom and non-superimposable to its own mirror image is said to be chiral molecule or asymmetric, and the property is called chirality or dissymmetry. So this is the condition for optical activity. Another, a molecule must be chiral and non-superimposable. Tomorrow I will ask, what is the condition for optical activity? Chiral carbon and non-superimposable mirror image is the condition for optical activity. So you can see here asymmetric carbon atom. Can you see here? You can see here carbon A, B, C, D. Sorry, my phone has struck. Something has happened to the Zoom, so I am not able to go back. Okay, so this is non-superimposable mirror images. Can you see? WW, when you take this and keep this molecule and keep on over this, what happens? The W will come here and the Y will come here. So non-superimposable mirror images.